These are the video solutions to unit test number 1, the non-calculator section. On the first problem, we were looking for a demonstration of knowledge of closed versus open circles on these intervals. So -6 inclusive to -4 not inclusive needs to have an open circle at -4, closed circle at -6. Similarly, x greater than 5 has to have an open circle on the 5. -√3 had to be closer to -2 than to -1 because -√3 is -1.7. And as we discussed in class, -1 to the 4th is equal to -1. For number 2, these were math facts. The square root of 361 is 19. We accepted either a whole number or an integer as the smallest subset to which 19 belongs because, in fact, whole numbers, there are as many whole numbers as there are integers, which is a really interesting set theory exercise. Square root of 2.25 is 1.5. That's a rational number. It can be expressed as a fraction or as a terminating decimal. Square root of 48 can be factored into the square root of 16 times the square root of 3, which is 4 roots of 3, and that is an irrational number. Number 3, we were looking to see, we were hoping that people would recognize this as 5 somethings minus 3 somethings to give us 2 somethings, and then distribute the 2 to get your final answer of 2x plus 2y. If you just distributed the 5 and the -3 over the sum x plus y and still got 2x plus 2y, then that's full credit. But again, we're looking for that making use of structure in algebra. For part B, this is just more distributive property, taking care of the 2 squared, turning that into a 4, and distributing this negative sign over to -5 as well as to +4 as well as to -x leaves you with 4 minus x plus 5 minus 4. The 4's cancel, you're left with just -x plus 5. You distribute the 3 over the -x and the 5 and you get x minus 3x plus 15 leading to -2x plus 15. This was assessment of recognition of properties of numbers. This is the distributive property, so that's true. Here, if you canceled a over a to get 1, then kittens would die. This is not a valid operation. This expression on the left is not equivalent to the expression on the right. We recall that distributive property is the distribution of multiplication over addition. We cannot distribute this exponent, so this is also a false statement. And here, this is just the commutative property of multiplication where order does not matter, so the statement is true. Number 5 is assessing your understanding of the box problem. So if the paper has the dimensions of 20 by 30, you cut 1 square of side length out of both corners, reducing the width by 2x and reducing the length by 2x. So the volume, which is height times width times length, is just x times quantity 20 minus 2x times quantity 30 minus 2x. The largest cutout you could remove from either side is 10, because if you cut more than 10 out, then you would run out of paper on the shorter side of the cardboard. So the domain is 0 to 10. We accepted 0 to 10 inclusive. For number 6, we're asking you to write simplified expressions for basic geometric formulas. So perimeter is the sum of all sides, so that's 5a plus 2b plus 5a plus b, and you had to combine like terms to get 10a plus 3b. Area is 1/2 base times height, and you had to simplify this, recognizing that the 2 and the 1/2 cancel to give you just 5ab as an expression for the area. For this problem, coming up with an expression for the money left over after buying soda and candy bars, you're subtracting the cost of the soda and the candy bars, the whole cost, from 12. So you could express it this way. If you distributed the negative sign and ended up with 12 minus 1.25x minus 0.65y, that was okay too. In number 7, we're working with fractions, evaluating expressions where the values that we're plugging in are fractions. So plugging in a 1/4 for A and a 2/3 for B. and then working with these fractions. So multiplying fractions gives you 3/4 here, and 2 times 2/3 gives you 4/3 here. Before we can subtract, we have to get a common denominator. So the lowest common denominator between 4 and 3 is 12, which means this 4 needs to have a factor of 3, which means I have to multiply the top and bottom by 3, which really is just multiplying it by 1. And when I do that, an equivalent fraction to 3/4 is 9/12. When I multiply 4/3 by 1, or 4/3 by 4 over 4, I get an equivalent fraction of 16/12. They now have the same denominator. I can subtract them to get negative 7/12. A common mistake I saw was to, what did I see? I don't remember actually. Oh, I do, now I do. It was seeing this as a mixed fraction as opposed to a multiplication problem. That happened a couple of times. So if that happened to you, I wrote it on your sheet and you can come see me if my comments weren't clear. For part B, again, evaluating by plugging in 2/3 for B and 1/4 for A and seeing that we're dividing them, and division is simply the multiplication by the reciprocal. So since we're taking 2/3 and dividing by 1/4, it's 2/3 times the reciprocal of 1/4, which is 4 over 1. And multiplying fractions does not require getting a common denominator, so that's just 8 over 3. For number 8, being able to recognize that this equation has no real solutions because this quotient on the left must be positive since the numerator and the denominator are both always positive. 2 is never negative, and x squared plus 4 is also never negative because x squared will never be negative, and then when you add 4 to it, its sum will be positive. I had a couple of students, in fact many students, say x squared will always be a positive number, and that's not true. X squared can sometimes be 0, and 0 is not a positive number. So I circled that if you wrote that, and didn't count off this time, but that is a level of precision in language that we are going to hold you to in the future. In this equation does have solutions because there are no range restrictions on either side of the equation here. So we simply multiply the whole, both sides by 6 to get rid of this fraction. So x over 6 times 6 is x. Negative 4 times 6 is negative 24. We got 18x plus 12 after we distribute the 6 to each term on the right side of the equation. I combine like terms by moving the 12 over to the left and subtracting x from both sides. So I get negative 36 equals 17x, and x is negative 36 over 17. For number 9, let's see, most common mistakes. The graphs are here. I guess the most common mistake on this problem was the third part. First, you have to recognize that x to the 1/2 is the same thing as square root of x, so that you can draw its graph. These instructions where one x value is not a positive integer threw a couple people for a loop here, because I think you recognize that you couldn't plug in a negative number for x, but you got to recognize there's lots of positive numbers that are not integers, such as 1/4. So if I plug in 1/4, the output will be 1/2, and I can plot that point. It's a helpful point to plot because it reminds me of the shape of this graph near the origin. Some people, there was a loophole in our instructions, and some people used the point 0, 0 for a second point on this square root of x graph. And even though in class we talked about how that's a trivial point, it actually does work, since 0 is not a positive integer. It is neither positive nor negative. So if that was your second point, we gave it to you. Finally, number 10, evaluating logs. 2 to what power gives me 256? 8. 2 to the 8th gives me 256. 2 to what power gives me 1/2? 2 to the negative 1 is 1/2. 2 to what power gives me negative 4? No such power exists, so the log base 2 of negative 4 is undefined. Log base 2 of 1 is 2 to what power gives me 1, and 2 to, 2 to the 0th gives me 1. Anything to the 0th gives me 1. So log base 2 of 1 is 0. If you have any questions, please just ask your teacher.